Welcome to Friction News Daily. Just earlier this morning, several different types of friction were discovered.
The scientific community was stopped in their tracks right at the hands of this amazing discovery.
These friction variations have been dubbed.
Man, well, I just experienced an excellent source of friction. Well, if you want to learn more, come with me.
Wow!
Now, our world is filled with evidence of science of influence. It is a force that opposes the motion of an object as they move past each other, or it slows over time. Friction acts at the surface where objects are in contact. There are four main types of friction: static, sliding, rolling, and fluid. Sometimes the friction and the mass of an object do not exceed your strength, and you have the power to remove it, or gravity is in your favor. Sliding friction occurs when the force is exerted on the object exceeds the force of the friction. The speed that the object moves can be affected by the mass of the object and the surface that it's sliding on. For example, moving a boulder across sandpaper would definitely be more harder than pushing it across smooth linear tiles. Now the first kind of friction we'll be discussing is static friction. You know when you have to move something where you just can't? It's too heavy? Well, that's because the force you're trying to use to disrupt the object's resting position is less or equal to the power of the friction keeping it in place. According to Newton's first law, an object at rest tends to stay at rest, so you'll have to try a little bit harder to move it more than it was already engaged in some sort of motion. So, now, imagine you were moving this little guy, and you were tasked with moving this giant block 3 times its size at least. Oh God. Unfortunately for him, he will be unable to move the block because of its mass. Oh God. The greater the mass of an object, then the greater the inertia and the great power of static friction. The third type of friction is rolling friction. Rolling friction is a force exerted on a rolling object. It acts to make the object stop rolling once its inertia has become equal to it. Like when you roll something down a hill, it eventually comes to a stop because the hill cannot go on forever. Not just a hill, but maybe even me.
Drop it.
Go. So, as you can see from those fine examples, when the car stops the opposing force, rolling frictions become too much for the object to continue moving, or I fall.
The friction.
Go.
Okay, so what do you have planned for us today, James?
Well, today we're going to compare the speed and amount of time that cars take to roll down a surface. We're going to have two different types of surfaces. One's going to be concrete and the other's going to be computer paper.
What?
Well, basically, all we're going to be doing is half of our ramp is covered with paper, and the other half of the ramp is just concrete, and we're going to see which rolls down faster.
How in the heck would that affect movement?
Well, let's see. The rougher the surface, the more disrupted the movement is, which causes more friction, which causes it to slow down. So if we have a smoother surface, such as the paper, it shouldn't disrupt the movement nearly as much, which will cause it to go smoother and then eventually longer.
Okay, so the unsmoothness of the concrete holds the car back from moving farther.
Exactly!
Alright, let's do this experiment.
1, 2, 3.
Whoa.
Wow, our hypothesis was correct.
Yeah, man, friction, what a drag.
Our last type of friction is fluid friction. Despite the misleading title, it's not all about water. Fluid friction also deals with the way objects move through gases as well as liquids. In fluid environments, air and water resistance have a huge effect on how an object moves. This is why planes and submarines both have similar streamlined structures. Fluid friction is what restricts objects' movement through the fluid. Whether the object is heavier or lighter than the fluid, it determines whether it rises or falls. The speed at which the object does either of these things is determined by the force of the motion. The total and overall force acting on an object is the net force. When dealing with balanced forces, the net force is always equal to 0, and the two equivalent forces cancel each other out. With unbalanced forces, the net force is equal to the two forces' values added or subtracted from each other. In order to map out all these different variables, there was devised a graph called a free body diagram. It looks like this. It represents all the forces acting on the object, or body, and the direction that it tends to move the object. They are important because in complicated scientific scenarios, keeping track of every different variable is tiresome and open to human errors such as forgetfulness or getting the numbers wrong. This diagram represents an object at rest. The force of gravity and friction are equal and opposite, so the object is still. This represents a free-falling object. Free-falling is a theoretical situation in which an object experiences no air resistance or fluid friction when falling, so the only force acting upon it is gravity. So basically, we can take all this out, and that basically allows this object to be only being controlled by gravity. This one represents an object moving at an accelerated rate, as depicted by the longer arrow pointing to the right and the shorter arrow pointing to the left. This signifies unbalanced forces, so the object is moving faster and accelerating rate to the right by 5 newtons. Did you like me, class? Was I good?
You suck!
Another example is a nice friendly game of tug of war. Both I and my faithful assistant are pulling on the rope with the same force, so the bandana doesn't move, left or right. Balanced forces equals at rest or constant motion. Unbalanced forces are forces that do not actually act upon each other. Or on the bandana, because that's what we're pulling right now, it moves from its original position to the left at an accelerating rate. Oh man. Alright, so I'm going to give a practical example of force body diagrams.
There's friction all around us. There are 4 main types: sliding, rolling, fluid, static. There are 4 main types, and I know when that friction brings, that can only mean one thing. And I know when that friction bling, that can only mean one thing. Friction is everywhere too, posing all emotion and movement, slowing down every force right now. Sliding friction slows down all stuff, cause friction everywhere too, affecting objects when you roll them. Fluid friction affecting in its fluids, static when you can't just move it.
Alright, well, these guys are after me, so